Is directly done, right?
So the way how it should be: requirements, then solutions, and then architecture. This is what you have.
Yeah.
Okay, so that it stays as it was initially. Because Matthew thought that it's a bit awkward in the sense that we have requirements, architecture, and solutions, but Daniel actually formatted the slides that it has requirements and solutions, and then the architecture how it fits in. He prefers that way, so it's all fine. It's basically reversed as it was today in the morning.
I see. Okay. Thanks, Ignis. Yeah.
Okay, welcome to NVO3. We get going, please. My name is Matthew Botches, Sam Alder in my chair. We have Ignis Vandonis, who's our secretary. Here is the note well. I apologise for the tiny font. We'll bring opera glasses next time. Okay, so blue sheets. So there's two sets of blue sheets going around, one down each side of the room. Please fill it in when it reaches you. Note takers. So we've got Ignis doing the minutes, and Tal's volunteered to be JavaScribe. Thank you very much to both of those. Right, this is the first normal meeting we've had in a while. So we've got if you've been to the previous IETFs, you'll be aware we've had this experiment running where we've been doing some round tables and on different topics, and we've had some success with that. That's generated some drafts in the security area. So we're now going to focus this meeting mostly actually on those security drafts. But we do have a really packed agenda. So please, if you're presenting, keep to your time slot. Otherwise, we're really going to have to cut you off. Thank you. Okay, so the agenda. Any comments on the agenda? One other thing we have in this meeting towards the end of the agenda is, in order to help set some context maybe for some more control plane work, we asked Jorge to give us an overview of the EVPN work in BESS that's relevant to NVO3. So he's got a short slot to talk about that later on. Okay, so milestones. So we haven't updated these for a bit. The chairs will go in and discuss these. I think probably we ought to update them again. It's about time. Document status. So we have one new RFC, 8151, which is the use cases for DC VPNs. Nothing in the RFC editor's queue at the moment. The multicast framework draft went through last call, and we did publication requests, so that's with Aaliyah now. And the other two documents of note is that we adopted the, actually there's a typo on a slide here. One of these drafts is the design team document for the data plane encapsulation. So that was adopted, and there's also a draft underneath that is adopted. Thank you. Okay, the other thing that we tried to do, we ran an adoption poll for 2 OEM drafts that were the output of the routing area OEM design team. That's regarding the overlay OEM header and CCNC on-demand CCNCB for overlay networks. There wasn't really consensus to adopt the drafts, but the chairs, we need to make some kind of progress in this OEM area. So the chairs have asked the protagonists on this to work together to try and resolve their issues and generate some more discussion on the list to try and move forward in the OEM space. Okay, thanks. So one other thing I should mention is that we will have one remote remote session from Elango for a draft Geneva update. So we're going to try and do that through Meet Echo in a moment. So I think first up on the agenda is Sami with the design encapsulation design team.
Yeah, good afternoon.
Sami, you have the front screen.
Oh,
Do you want this as well?
this is easier. Okay. So yeah, this is an update for the design team in CAP draft. So yeah, since last update, the draft became our group draft, as Matthew mentioned here. So I'm going to be discussing mainly the changes that went to the draft. Okay. So we did a couple of removal here. We removed the backward compatibility to VXLAN as a requirement. There were those updates were to reflect the comments that was sent on the list and many discussions that happened on this draft over the NVO3 list. So as I mentioned, we removed the backward compatibility as a requirement to VXLAN. The other thing we removed is issues with extending the bit flags that was under GU as well in the draft. Then the following changes are more addition or clarification to the document. For example, we added a recommendation for the control plane to have the working group work on a draft for guidance on how control plane would help in option processing and as well ordering and option size, the next protocols that could be signaled with Geneva using control plane. So the control plane participation in general was that this is a dynamic or a centralized control plane. As well, we clarified the transit node rule. So what kind of option will be processed by the transit node. So we clarified that only a subset of option here will be looked at by the transit node. One more thing as well we clarified was a statement we made about how different software modules on the device, on the VTAP itself, can handle different options like Mac learning and security options that could exist on after the Geneva tunnel header, right? So for the recommendation section, which was the main section on which we discussed why we recommended Geneva and so on, we added some more as well statement or more points regarding Geneva. So how Geneva is used today in production, especially the Geneva options, how hardware as well is currently supporting Geneva tunnel, Geneva TLV's parsing. As well, we clarified how the design team addressed some usage model while considering the requirement, for the implementation of Genevan option for both software and hardware. There were a few clarifications as well that we made for statement we had in the recommendation about early bit assignment. This was related to the GU in CAP. So we clarified that too on how how processing for an option that could be in an extension for a bit extension for GU will be processed, and I think you can look up the explanation in the draft. As well, we added some clarification about the requirement to address variable lengths and different subtypes from where this requirement came. So we added clarifications that this came from OEM and as well came from some security extension. We added more clarification on the OEM aspect because there were some requirements made from OEM about alternate marking and the need of 2 bits. And I think recently there were some discussion about how can we live with 1 bit instead of 2. So, so I think the OEM in general usage and usage models justification need to be discussed more. So there was some discussion about removing or repurposing the current OEM bit in the Geneva header, and so we need to, I think, as Matthew mentioned, to talk more about how OEM can be addressed in general, and how will that impact the Geneva tunnel, right? We recommended for Geneva to follow the fragmentation recommendations that was made for PUI. For both layer 2 and layer 3 VPN as well. And we gave the section from the PUI document here that discuss how fragmentation should be handled. There was some discussion as well on the critical bit on the Geneva draft. And, you know, and we recommended to have some text on how critical bits can be used with control plane specifying the critical options. So there was some discussion on that, and the things in the Geneva document, Ilango will as well be addressing some of the comments here, including this one, that we, or some of the recommendations that we made in the design team in CAP document. We as well added for the telemetry option, a recommendation for a use case that require 256 byte option in a single TLV. There was no consensus to extend the single TLV length to 256, but I believe further discussion is needed on that aspect. So that change as well will require some discussions that we need to do with the Geneva tunnel in CAP or with the Geneva authors, right? We finally, a couple of things here. We changed the DTLS reference in the DT in CAP document, replace it with IPsec and DTLS. So not only you know, mentioning that DTLS is the only way of providing security, protection, and integrity here. So IPsec, ESP, and AH can be used too. So as well, and we finally recommended, of course, the work group to work more on security option for Geneva and how those can be addressed. So I think with that, yeah, with that, I think those are the changes we made or we addressed in the document, the work group document, the IETF NVO3 in CAP document. But as well, there were some more comments that and discussion happening now on the list, on the mailing list, and we'll be updating that in the next version. Discussion were related to the calculation of the entropy. As well, some discussion were related about traversing NAT or doing some SNAT. So those are some of the discussions that's happening on the list. So we'll probably address those comments and may add more sections to the document or may add more updates. So any comments?
Hi, Tal Mizrahi, Marvell. I'm a co-author of this draft, so I have a question which is more intended to the chairs. So now this is a working group document. I guess it means the recommendations are adopted by the working group. And at this point, VXLAN GP is still a standard track draft. So my question is regarding the future of VXLAN GP. Is there a future? And if so, when will the recommendations come into effect? Thanks.
So I think what we said when we had chartered the design team, and when the design team came up with a recommendation for Geneva, was that the other encapsulation drafts would have to wait for Geneva to be sent to the ISG, adopted, right? And then following that, so when the working group is basically done with Geneva, we can progress. If people want to progress as an informational document or experimental, we have yet to determine the exact status of it. You know, the other drafts like VXLAN GPA. I think there's some changes that need to be made, for example, to the VXLAN GPU draft anyway at the moment. For example, it's obviously, it says standards track on it, and we've said it won't be standards track. But the way it requests an IAN allocation is only valid for standards track documents. It wants standards action. So there's a few things we'll have to fix in the draft to make it appropriate if that's what you want to progress.
Greg Nurse, KZT. So in your view, there are open questions that were mentioned, listed in data plane design team presentation. How they related to the progress of Genevieve document?
They are being addressed in the Genève document. Elango has a presentation now on Genève to discuss how those are being addressed.
Yeah, so Elango is going to present, so you may want to ask the question at that time.
Because one of their open questions, I believe, that related to OEM and
Correct, yeah.
bit use. So again, I don't expect the answer now, but just I'm saying that that needs to be clarified.
Yeah. Actually, all the recommendation and all the comments that was put on Genève are going to be being addressed. Because some of those things are still discussions, right? So cannot be addressed after the discussion conclude, right? Okay, thanks. Any more comments? Okay, thank you.
Okay, so next is Elango. Hopefully this is going to work. I think you need to go to the mic. Elango? What's going on here?
I think Elango has to join the mic queue.
Yeah, he's on here. Oh, yes.
Yeah, I think so.
Elango, can you hear us?
He can't respond. He has to come to the mic.
Yeah, you need to come to the mic, Elango. Okay, if this doesn't work, because we've got a very tight agenda, I think Sam is going to do it, right?
Should we wait for Elango?
I think we need to go ahead.
Okay, sure. So yeah, I'm doing this presentation on behalf of Elango. This is Elango, sorry, and this is Genève
hear me?
draft or Genève tunnel.
Are you able to hear me?
Oh, we can hear you now.
Yes, okay,
There we
thank
go.
you. Sorry.
Thank you. All right.
Yeah, first of all, thank you for the IETF and the meeting organizers for providing me the remote presentation opportunity. So I'm going to cover the draft Genève update. We are closely coordinating with the design team so that the questions that were asked in the previous session, I'd be addressing this during this presentation. Let's move to the next slide.
Okay.
Yes. So this is a recap of the draft Genève, the previous version when we did this update. And the update was based on the recommendations by the design team. And as Sami mentioned earlier, the first one of them is the control plane for the constraints for the options. So what we did this one is this has been addressed in section 4.2.1. Where we stated that the control plane can limit the number of option TLVs and TLV ordering, size of TLVs, and what TLVs can be transmitted between the NVE endpoints. So all those constraints were added to this section, and this helps the software as well as the hardware implementation of the Genève in the endpoints. And also, if the control plane should have the ability to describe the supported TLVs to the endpoints. And also, we mentioned that in the absence of the control plane, an alternate configuration mechanism may be used for this purpose. And as I said, that these things are all these text has been already included in the draft in the current version in the 04. So let's move on to the next slide.
Okay.
Yes. So after that, the changes, like further discussion were happening in the mailing list, as well as some of these recommendations have been captured in the design team draft, the recent design team draft upgrade. So I'm going to go over the recommendations here. The first one is the follow the recommendation for the overlay services like the PWE3 for the L2, L3 VPN. The main objective for this request is to prevent fragmentation. So one of the ways this, the PW3 draft is addressing that one is, or the RFC is addressing that one is guaranteeing a larger MTU size for the tunnel overhead. So we have a similar draft in section 4.1.1 in Geneva that outlines, best practices for preventing the fragmentation. Pretty much the same thing, like increasing the MTU size in the sense so that you don't have the fragmentation, and even if there is a fragmentation, that fragmentation should be done before the encapsulation part of it, so that so that the packets or the frames don't get fragmented in transit. And the next one is recommend to add the OAM consideration. And there are two different discussions that came up as part of the OAM. One of them is the 2 bits for alternate marking for the performance measurements. And there was also another question related to, do we really need the is there a need for an OAM bit? And or if so, then clarify the need for the OAM bit. And there are other OAM drafts available in there. And in general, I would say that the OAM proposals and use cases need further discussion before we go ahead and make the changes. If you look at the draft test, which talks about the OAM, in fact, that draft suggests or the proposes the use of the existing OAM bit in order to disambiguate between OAM frames versus the normal data frames. And also, the draft also proposes further an OAM channel in order to carry the OAM messages as well. And so this is just an example, but there are other proposals as well as on table. So we wanted to allow some time for the OAM discussions to mature, and then based on that decision, then we will go ahead and then make any changes as needed. Next slide, please. The other one is the recommendation to provide additional text in order to clarify the usage of the critical bit processing. Of course, the critical bit is helpful in options processing, both in software and hardware, and more specifically in hardware. So it allows quickly to look at the critical options bit. And if the hardware is capable of processing the options, it will continue to process the options. And if it is not capable, it also allows the hardware to skip over the options and then process the rest of the payload before it forwards the data upstream or to the higher layers in the stack. So that's one of the advantages of having the critical bit, but and that has been clarified, or if it is not clarified, we will add additional text in order to clarify this information. And the other recommendation is to increase the single TLV option to 256. This one was specifically for a telemetry use case, and this was discussed during the previous roundtable as well as during the working group meeting after the roundtable. And there was no consensus regarding this use case. There were multiple discussions happening at this point. For completeness sake, so we wanted to bring this up here so that the working group has an opportunity to look at that and comment on this one. And based on that, we will go ahead and make any changes if needed. But one point I would like to state that one is that also means that it will limit the options that can be carried in Geneva. And we believe that there will be at least some other options that will be available. And so in case of a telemetry, if telemetry option takes away the entire space, then it's going to be difficult for carrying other options. And also, in one of the examples that was quoted is the P4 INT, which is specifying an example use case of how to carry the telemetry, and that same document mentions about how you can carry split the information into 2 different options to carry it over Geneva. So that's another example I can quote you. So as I said, right, this requires further discussion before we effect any change to the draft. And next slide, please. So
Okay.
after some of these information has been captured, as I mentioned, in the design team draft, and then we have been closely coordinating with the design team to make sure that we capture all those points when we make a draft update on Geneve. And even after the design team draft was published, further discussions were on the mailing list, and we are closely observing that one. And based on how the discussion progresses, we will make the necessary update as appropriate. With that, thank you. That's the update I had. And any questions, comments?
Okay. No. Well, thanks very much, Rango.
Thank you. Thank you very much.
Okay. So next is the security requirements. Daniel.
Hi, so I'm going to go through some of the security requirements maybe foreseen for Geneva. We have 10 minutes. So, is that a very old presentation? Well, we will present 4 drafts, and this is the requirement draft. So then we will go into the solution space, where we will describe how the protection is actually instantiated, and then how these different solutions are coordinated. So that's a security architecture. So the requirement. So as you can see, we have NVE, and then we have some Geneva forwarding elements. So the packet has to go from one tenant through the NVE, so the different forwarding elements back to a tenant system somewhere else. So the Geneva overlay is really between the tenant and the infrastructure. So it has different goals. One of those is, as the Geneva overlay is managing the different tenants, so it has to isolate each of the tenants and make sure traffic is not mixing between the different virtual networks. And it also has to protect all this traffic from the infrastructure, which can be seen as a different entity. And also the overlay network has to be quite robust. So these are the 3 goals. Tenant isolation, so you want to avoid that some traffic goes into one virtual network. You want to prevent that some traffic that leaks outside the virtual networks be analyzed and then re-inject. And you want also maybe to provide an additional service to the tenants, which is where we'll protect your traffic to an infrastructure we might not trust. Then the overlay network should be robust, which means robust against replay attacks, and against traffic modifications. And of course, we should be protecting the traffic against the infrastructure. So the first thing is that tenants might encrypt their communications using IPsec, for example. Well, in this case, it won't be part of Geneva, the Geneva overlay, to provide some of the protections. In that case, the tenants are somehow providing some of the ways, but to protect their communications. So this is not in the scope of Geneva to provide an IPsec tunneling between the different tenants. That's really the scope of the tenants. So, what we considered is mostly that any nodes can be performing an attack, like injecting some traffic. And that any nodes on path must be able to read the Geneva header, and the destination must be able to authenticate the incoming packets. So that's how we base the analysis on. So here is some of the requirements we went to in order to avoid traffic injection. So when you're evolving within a virtual network, You don't want actually any packets going, well, illegitimate packets going to your virtual network. So the first requirement is a GNV NVE must be able to authenticate the GNV header, including the immutable GNV options. This means that a GNV packet where you have switched one bit in the NVEI won't be able to reach the modified target, for example. But that's, of course, not enough. So we went to a GNV NVE must be able to agree that the authentication also includes some of the options. Of course, the options do not change. And it should be also include some parts of the GNV payload. So the reason we think it doesn't always need to include the GNV payload is, for example, if you only want to authenticate a single GNV option. So in that case, the payload is not involved. But the other reason we don't want to, well, we may not want to include the full GNV payload is that during the Chicago session, we've been told that it would take too much resource to include the whole payload. And for example, if the traffic is protected with TLS or DTLS or IPsec, then you can lower the need for resource by limiting the amount of data you encrypt. So that's some of the reason. Then we also mentioned that, well, requirement 3 is that a GNV intermediary forwarding element may be able to validate the authentication before the packet reaches the NVE. It clearly means that if it's well provisioned, encryption or authentication and validation can be done outside the NVE, for example. And that when an intermediary forwarding element wants to include an authenticated GNV option, it should be able to do so. I don't know if there are any comments or remarks, but I think you feel free to jump on the mic. So some next requirements. Well, we would like that even though some GNV packets are authenticated, nodes, forwarding nodes that are not supporting that authentication option or validation can still work and forward the different GNV packets through the data center. Requirement 6, so we have split that one in 2 different requirements. You should be able to apply different type of security to the different flow you have. And then the big question is how you characterize the flow. And well, we assumed or we required that you should be able to describe the flow from the GNV clear text packet, which includes the GNV fixed header, the options, and eventually some part of the payload, the GNV payload. The reason to include some part of the GNV payload is still if you already have some kind of protections. So you might be willing to say, well, I'm not going to encrypt the same way a payload that is not protected at all. Well, the protection is going to be different from one payload which is already protected with IPsec or TLS. So that was for traffic injection. And now we have some different, if we consider redirections, it starts with, well, a leak of some of the traffic, and then the traffic is being re-injected. It could be modified or not. So re-injection is mostly the same as injection, and leakage is a little bit hard to, well, it's hard on a protocol to provide some protocol requirements to avoid leakage. It's mostly part of how you deploy the GNV. So instead, what we focus on is how, if you can't prevent leakage, is how you can make leakage useless by not revealing any kind of information. So even though you have IPsec packets, even though the tenants are performing IPsec, for example, you still reveal some information. So like the MAC IP addresses used, the different MAC addresses, the different IP addresses. And if you use TLS, then you reveal also some of the ports. And well, that's still information. So this is why we still need to provide, I mean, the use of IPsec by the tenants is not sufficient. So what we put as a requirement is that a GNV NVE must be able to agree that a GNV payload or portion of it is encrypted. And this includes GNV options that are not intended to be updated. Requirement 9 is a GNV intermediary forwarding element must be able to insert an encrypted GNV options. And then, well, forwarding elements that do not perform encryption or that are not encryption or decryption aware should be able to process the packet anyway. So do we have any comment, suggestion so far? Any strong disagreement?
Is this the end of the presentation, or
No, but you can.
So I'll wait a couple of minutes.
Okay. So now that we worked on we have only addressed how to isolate the tenants from an attacker. So now the second part is how we can make the overlay robust itself. So, well, the type of attacks we consider at that level is an attacker that is replaying some traffic. So he can sometimes modify the header, but even though he's not modifying the header, if you replace an OIM traffic, well, usually you've designed your networks for a given amount of traffic on each category. So if you're increasing the volumetry on OIM traffic, for example, you might disrupt the network or so on. So, or if you're adding options, it's changed the way you're engineering your network. So basically the two requirements we came to is to have anti-replay mechanisms. And well,
Can you speed up?
yeah, okay. And the other thing is that, well, we should have a binding, make it possible to bind the payload with the header. Because if you have a header that is perfectly protected and a payload that is perfectly protected, you replay that overall, you can change one or the other. So both have to be protected and bound together. Isolation, well, isolation is mostly encryption. So as has been explained in how to protect the tenant's traffic from leakage. I think so. Question?
Tal Mizrahi, Marvell. So first of all, thanks for putting together this draft. One thing that was missing for me to understand the entire picture was threat analysis, to understand the set of threats that we're trying to deal with, the set of attack vectors, and then maybe to have kind of a mapping between requirements and attacks, because this would allow us to understand the priority of the requirements and to make sure we haven't forgotten any attacks, or just to make sure that everything fits together.
Okay, so are you also suggesting that from the draft, or?
Yes.
Okay, so yeah, yeah, we can discuss that. We should improve that. I thought I had done it, so maybe we can discuss that. And of course, that's things that has to be done.
Thanks.
Hi, Suresh Krishnan. Yeah, thanks for putting it together. I had like a couple of questions. Like first of all, on the requirement stuff, right? I would like to see some kind of description on like why just encrypting the UDP payload is not sufficient, right? And what's the advantages and disadvantages doing that, right?
So encrypting the UDP outer?
Yeah.
Okay, yeah.
Okay, so like that gives you like some benefits and some disadvantages. So like, that would
Yeah.
be something that's good to have. And the second thing is,
Just one comment about this question. I think we addressed this comment, why not taking the outer in the solution space, but maybe we should include it in the requirements then.
okay, sounds good. And the other thing is like the document structure is a bit hard to handle. So this has the exact same document structure as IPsec pretty much, right? So there's an architecture and I think it's a bit too heavyweight for this, right? Like, so, and they're like pretty simple documents. The crypto suites are somewhere else. So like, maybe we don't need all that complexity to keep all these things separate. Maybe one document could cover the architecture and the options together, right? Like, because, right? Like, so the requirements being separate is fine, right? So thank you.
Yeah, if we can come with something that can be put in one draft, it's of course no problem.
Right, and it is simple enough at this point to do it, right? Like, and if it becomes complex, maybe it's worth splitting out. But right now, I think it's the right thing to do.
Okay, thank you. So I don't know how much time do we have. We
10 minutes. Yeah, for pretty packed.
So I should do the short version of that.
Yes.
Okay. So on the slides, we started with a discussion on basically why the current DTLS solution and why the current IPsec solution does not fill exactly the requirements, and also why we need to find out a specific solution that is specific to Geneva. So I'm going to skip those slides, but I'm happy to got some questions. So as mentioned before, basically what we are doing is has a strong IPsec flavor, and we use the anti-replay, the authentications. Well, this is GAO is the Geneva authentication option. So we use IPsec AH for that, and we adapted those for Geneva. So it enables the authentication of the fixed header, the options, a subset of the options. We believe it does not impact forwarding nodes that are not aware of these options. And it also enables someone in the past to insert an authenticated options or to insert an options on an authenticated packet. So it looks very much, this is a Geneva option, which looks pretty much like the IPsec AH option. The only difference is that the ID used in IPsec is called the SPI, and it's 32 bits long. But in our case, because it's based on the NVE, maybe a shorter size is sufficient. And the other thing we added is clearly that we use the covered length, which is in AH by default, the full packet. So this is how it works. We have the Geneva fixed header, some Geneva options that are not covered, and then we indicate that from that point, with the GAO option, we just indicate from that point up to the covered length, this is going to be authenticated. So things that are outside the covered length are not authenticated, and things before the GAO, between the GAO and the Geneva header are not authenticated either. I think in the design, one of the advantages of doing so is that when you see the packet, you know exactly what is going to be authenticated and which options is going to be authenticated and which are that are not going to be authenticated. And you also have the cover length, so you can process the packet as that. Well, the processing is very much like the IPsec, so I'm going quite fast. Well, the encryption option, so it's really like the IPsec as well, ESP. One of the differences is that usually in ESP you include the encrypted packet into that option, but GNV options have some limited size, so we basically adopted the same design as for the authentication, which is we put a marker, the GNV authenticated option that says from here we are authenticating this covered length, encrypting this covered length of amount of data, and the signature is in the option itself, so that's not an issue problem. So basically you will have the fixed header, the GNV option that are not protected, then the encryption option that says from here it is encrypted. You have the cover length which is the encrypted payload. So you have to decrypt that, remove the options, and then you're back to normal. Another thing we changed is that we usually use authenticated encryption. So, and in our case, the GNV fixed header is also authenticated, so we can bind the packets together, the two parts of the packet. So we will see another proposal later, and we will be also to compare those two proposals, but we are happy to see any comments on that. I think that's fine for this one. So we've described on how to authenticate some packets in various conditions. We have described how to encrypt some packets. The two options can be combined together. Now we need to be able to orchestrate all these options together according to flows. So this is really the purpose of the security as architecture. From one flow to be able to associate the right security options, and then when you receive the packet, to be able to decrypt, validate these protected packets, and then, which is important, to make sure that the resulting clear text packet match the security policies. So it looks complex, it's not so much complex, but it's still IPsec. So the model we had is you have GNV, and you have what we call the GNV security model. So you have a clear text GNV packet, it is processed, protected, then the receiver got a protected GNV packet, you process that and give back a clear text packet. So, well, the policies are, when you have received a clear text GNV packet, you need to know if you have to discard it to bypass that way, so which means not protect it, or to protect it. When you have to protect it, you need to have some security material ready. So that's what we call the security association. So the policies say, do you have to secure it? How to secure it? That's a security association. So the big question is how we would define a packet needs to be protected or not. So we use what we call traffic selector because we have to read from the packet what needs to be, well, if the packet needs to be protected or not. And so we are listing a few fields. So the fields include the fields of the GNV header, as well as some fields of the inner packet. The real question is, currently, I think we have been a little bit exhaustive, but a field should be mentioned if it makes sense to say, okay, according to this field, we might need different security policies. If, for example, I'm just taking the example of the first field, the GNV version. If it makes no sense to say, well, if this is version 1, I'm going to use this security policy, while if it's version 2, I'm going to use this one. If we don't have this kind of distinction, then the field should not exist. So at that point, well, if you have any, we can reduce the number of fields. Currently, just added those, and we'll see. So we have some additional selectors. We do not only proceed to a given security policy according to the fields of the GNV header, but it's also according to the nature of the payload, the GNV payload, which is the packet sent by the tenant. So, well, you need the next, if you want to make some distinctions between DTLS, TLS, IPsec traffic from the tenant, that you need the next header and the port and these additional selectors. So if that's too complex or if it's not enough, well, it's time to say it. Well, outbound processing. So basically, you receive the packet according to the traffic selectors you have designed, which that is the security policy. You mentioned, okay, this packet has to be protected. Then you apply the different security options, which means that currently what we foreseen is that in a control environment, you will provide the security policies and the security associations. So, which means the cryptographic material necessary for the security. But then, in the next step, we will also be able to use IETF, so you can have a negotiation between the different NVE and have something a little bit more autonomous or less controlled. When you have an inbound processing, so I will go fast on that slide, but the only thing I want to, well, the reason we need that security architecture is not that we want to make things complex, but if you receive a packet and you can't validate the signature, it's fine. But actually, then you need to actually check whether the corresponding security match the policies, because suppose you want to secure the ping, and I'm sending you an HTTP packet. When I receive the packet, I don't know if it's a ping or HTTP. So I'm going to decrypt that. I say, well, fine, it's a good packet. But then I realize it's an HTTP and not a ping. So I have to double check the security policy and say, well, it is not what I intended to. So I have to reject. So that's basically the scope of the security architecture. TLS does not make it simpler. It's just because it's a different model, TLS is being used. But that's the reason we need security architecture. Any question? Oh, welcome. And I think I didn't take too much time.
Okay, so any questions?
Mitchell Circa here. It's not a question. Daniel, it's Genève, right? Not Geneva.
Oh, it's not. How do you pronounce that?
Do we have a Geneva author in the room?
Well, thank you.
Okay, thank you. So I think next is Sami. Yeah, if you haven't signed the blue sheet, I think they're coming around again. You put your hand up if you haven't signed the blue sheet, please. Yeah, there's a few towards the back. If you just pass it backwards.
This draft is a proposal on how to carry IPsec over Geneva. IPsec define two protocols here, which are the encapsulation security payload, or ESP, as well as authentication header, or AH. Those are two different IP protocol type, 50 and 51. So here we are going to be discussing how can we carry those protocols as next protocols over Geneva. So this is the frame format here for carrying ESP over a Geneva tunnel. So we have shown here the outer IP and the outer Ethernet header. Of course, the UDP port for Geneva, or the UDP header, followed by the Geneva header. The next protocol in Geneva will be 50, which is ESP. Then we have the options. Then we have the ESP header, and then the inner payload. Of course, given that the inner payload is could be layer 2, then we need to have another header to carry the layer 2 if the inner payload is going to be layer 2, which most likely will be the case here. And this is why we need an Ether IP header of 2 bytes or GRE header of 4 bytes. Then the inner layer 2 packet, of course, the ESP trailer and the ICV. So I've shown here the part that will be encrypted is going to be the inner packet, starting from the after the ESP header to the trailer, to the end of the trailer. And of course, the authentication or the integrity will include as well the ESP header. The ESP header next protocol could be Ether IP, as I mentioned, or GRE, and those are IP protocol. And the GRE protocol type, of course, here will be set to Ethernet if we are going to be carrying Ethernet. So this is how can we carry ESP or protocol 50 over Geneva. The next slide here is for the AH. And AH again is another IP protocol of type 51. And in here, same idea. Is that the outer IP header, we have the outer IP header for the Geneva tunnel, then the UDP port again, or the UDP header with the port equal Geneva, then the Geneva header next protocol is going to be 51. Then we have the option TLVs, the authentication header of the IPsec then again the GRE and the inner payload. In here, what's being authenticated include the outer tunnel header. Of course, except for what's defined under IPsec as mutable fields. Those are the fields that are not included in the authentication. So in here, the idea is that some of the option TLVs could be included in the authentication while other could not be. And that will depend on the control plane associated with that option TLV as we are defining them. So one can envision that some of the option TLV could be inserted by midpoint, and those will not be authenticated by the H here. They could be authenticated by other mechanisms, but not by the H. So H, by the definition with IPsec only authenticate the non-mutable fields, right? Here, the control plane consideration is the draft. We are talking about, we are envisioning that there will be a control plane between the NVs, whether centralized or distributed, that are going to be negotiating or signaling that the next protocol carried by Geneva will be ESP or H. So now the endpoint will know that the Geneva tunnel will be carrying the IPsec ESP or H. As well as that control plane, as mentioned in the other presentation, can be used to signal as well what kind of option we are going to be carrying on the Geneva tunnel. So once the two NVs agrees that they have to carry ESP or H as next protocol, then this could be a trigger for negotiating the security association, right? That can be used here. And establishing the SA or the secure association. And same thing, mechanisms defined in IPsec can simply be used here as well to do the key exchange. So this is leveraging what exists in IPsec to do the secure association and as well to set up, establish a secure association and as well to negotiate the keys. And whatever can be carried again over those secure association, whether this is going to be policy based or routed, meaning we can route some packet over that secure association, can simply be used to, right? So this I think that's it. So, in terms of next steps, definitely would like to get comments more from the list.
Yeah, but it's again, just to break the ice, can this not be used with VXLAN?
VXLAN doesn't carry an X protocol today, right? VXLAN does not have the next protocol to carry ESP or carry any IP or Ethernet protocol, unlike Genève or other encabs that are defined.
Actually, you can encapsulate within IPsec AH or whatever.
Here we are talking about carrying ESP over Genève, right? Because Genève has an X protocol on which you can specify that I'm carrying ESP or carrying AH or carrying whatever, right? While VXLAN only have VNI, does not have an X protocol on it. So you cannot carry ESP over VXLAN. You can use ESP before VXLAN, before the UDP, and encrypt the whole packet. So that's another option. I think here the draft is about carrying ESP over Genève, not using ESP to encrypt the whole payload of IP tunnel that can include the UDP and the ESP as well.
Okay, understood. Thank you.
Okay, no problem. UDP and Genève, sorry, or VXLAN.
Hi, Tal Mizrahi, Marvell. So I hope there are IPsec experts here who can correct me if I'm wrong, but I believe that at some point AH was deprecated, and the IPsec no. At some point there was a recommendation to use ESP with null encryption instead of AH. Correct me if I'm wrong.
Yeah, it's a debate that comes every 2 or 3 years, but AH is still there. Well, we have a draft at the ISG that is providing recommendations on how to protect the AH. So
Stand corrected.
Okay, thanks. Any more comments?
No.
Okay.
Okay,
Thank you.
thanks. So next is Jorge. Is he there? Yeah.
Good afternoon. So the chairs have asked me to present a little bit of what we've been doing in BESS for data centers or for DC overlay networks. So this is my own view from a participant's perspective. So I want to talk about EVPN briefly in just 1-2 slides. Then I wanted to touch based on the work we've been doing in BESS for NVO3 networks. A little bit of EVPN in the industry today, and finally an open discussion about what else we need to do in BESS for NVO3. So EVPN in a nutshell, what is EVPN? Ethernet Virtual Private Networks. So it's basically specified in RFC 7432. And it's basically, the original idea was to have a multi-point layer 2 VPN operated as we do with IPVPNs, right? Where the MAC addresses and all the information you need to set up flooding trees is distributed by multi-protocol BGP. The main objectives in RFC 7432 were first to replace the old flood and learn behavior that we have in traditional Ethernet networks with BGP, right? So we want to distribute MAC addresses with BGP, and that is actually giving you a lot of control that you can use to detect things like MAC duplication or things like MAC protection, or allows you to have a very quick MAC mobility, right? So it makes it a perfect analogy for the data center. The other objective was to have an efficient way to deliver multi-destination traffic or bump traffic. And the other key feature in EVPN in 7432 was multi-homing. So EVPN supports not only single active multi-homing, but all active multi-homing, which was really probably the first standard-based technology supporting this. So since 7432, EVPN has evolved quite a bit, and there are a lot of drafts and documents that explain the evolution of EVPN. Is now a unified control plane technology that allows you to have pretty much all the services you need. So ELAN, E-line, E3, but also layer 3 services and cloud DCI services. The good thing about EVPN is it's pretty flexible. You can extend it. It's transport agnostic, so you can use it with any tunnel. And it has a lot of advanced features already there. So if you had to explain what EVPN 7432 is in just one slide, you could think about it like this. It's actually a VPN that you define in a bunch of Ps in the network. The instantiation of a VPN in a P is called MacVerve. A group of MacVerves for the same VPN is an EVI, so an EVPN instance. And then within an EVPN instance, you can have one or multiple broadcast domains, right? And each broadcast domain, if you have multiple, basically is identified by an Ethernet tag in the control plane. Now, more characteristics of EVPN. So obviously, connected to those Ps, the attachment circuits, you can have customer edge devices, you can have hosts, you can have VMs, you can have routers, switches. The MAC addresses that you learn on those attachment circuits can be learned dynamically, statically through the management plane, so there's no limitation there. But then whatever you learn at the access, you can actually distribute in multi-protocol BGP using MAC IP routes. Those MAC IP routes, they encode the MAC and IP information of the attached hosts, and those are advertised along with a label and a BGP next stop. Now, the tunnels that you have among all the Ps that are part of the same EVI can be anything. Can be MPLS tunnels, including point-to-multipoint for bump traffic. We also support like PVB encapsulation over MPLS tunnel. That's what we call PVB EVPN. But we also support NVO3 tunnels, right? And nowadays, the most popular option is, of course, VXLAN. Finally, one of the key features in EVPN is multi-homing. Single active multi-homing, which means per VLAN load balancing from a CE to a group of Ps. And if you have single active multi-homing, there are also nice features like mass withdrawal that allows you to have a uniform failover, irrespective of the number of MacVerves that you have in an Ethernet segment. But especially something very appealing is the all-active multi-homing. So that is the ability of having per flow load balancing from a given CE to a group of Ps that are part of the same Ethernet segment. Along with this all-active multi-homing, where you allow this per flow load balancing from the CE to the network, we have this aliasing function that is providing the same per flow load balancing from a remote P to all the Ps in the Ethernet segment. So this is pretty much 7432. But as I said before, since 7432, EVPN has evolved a lot. So we have a lot of documents. And here you have some of the most relevant documents we have for EVPN. Above the dashed line, you have a bunch of documents. Some of them are RFCs, some others are already drafts in last call. And they pretty much define all the services that you need. And some of them are specific to the use case of the data center and the DCI, right? Specifically, you have here the EVPN overlay draft that talks about how to use EVPN for overlay tunnels like VXLAN, NVGRE. You have the DCI EVPN overlay draft that talks about how to connect overlay data centers to a WAN. And you even have the inter-subnet forwarding in the prefix advertisement draft talking about how to provide inter-subnet forwarding using EVPN. But not only that, so below the dashed line, you have many more documents extending the feature set of EVPN. And if you look at the website, the best tracker, you'll find more than 20 individual EVPN related drafts. So it's a very active and dynamic technology. We keep expanding it. So why is EVPN used in data centers? So you can have the base specification in the EVPN overlay draft, but the idea is that modern data centers are based on a clause-based architecture and IP fabrics, right? So it's all IP. All the links are routed, and on top of that, you need multi-tenancy with intra and inter subnet forwarding, right? And obviously, in order to have layer 2 and layer 3 on top of this IP fabric, you need IP overlay tunnels. And nowadays, VXLAN, as I said before, is the most popular option. Why do we need a control plane for VXLAN or any other IP overlay tunnel? Well, first of all, you need to auto-discover the remote VTEPs. So when a given VM in a subnet needs to talk to someone else in a different leaf or data center gateway, it needs to know how to reach that leaf or data center gateway, right? The other thing you need is to somehow distribute the MAC and IP information of the different hosts in your subnets. And you also need some more advanced options. So EVPN is a perfect fit for the data center, for an NVO data center. So it provides all the basic control plane needs that you have. And as an example here, you have 2 leaves, right, with a VM attached to each of them. And then you have a data center. So you have the same subnet for a tenant configured in the 3 of them. The inclusive multicast ether tag route, which is one of the EVPN route types, is providing you with this auto-discovery function. So the 2 leaves can send this inclusive multicast route, and the data center gateway can actually learn that those 2 VTEPs are associated to VNI1, and they are part of the same flooding list. But not only that, but when the 2 leaves, they learn the MAC and IP addresses of the VMs, they can actually advertise MAC IP routes with that information along with the VTEP, the associated VTEP and VNI. So the remote node is going to add that information to the forwarding database and also to the ARC table, etc. You can also do advanced things with EVPN, like inter-subnet forwarding. So if the same tenant has a different subnet, a red subnet, which is not defined in all the MVEs, you can use EVPN with special route type to propagate or to advertise prefixes, right? And to install those prefixes in an IP routing table. And you have other things that you can do with EVPN. You have some examples here in the slide. Now, EVPN in the industry today, so is not only a lab exercise or a scientific paper, it's actually deployed widely everywhere. So, and you have multiple implementations, hardware-based, software-based, and the proof that we are doing a great job in the IETF is that actually it's EVPN interoperates across different vendors, right? And here you have an example. So we do every year this interoperability event run by the EANTC. And for 2 or 3 years now, we are testing EVPN across different vendors. And we are testing very interesting scenarios and very, I would say, in a successful way. So that's great news. So EVPN works, and it works across different vendors. Now, and this is an open discussion, so what else do we need to do with EVPN for NVO3, for this working group? So obviously, we need to support new encapsulations like Geneve, and there's a first attempt. I think Sami is presenting tomorrow this draft about how to use EVPN with Geneve. And I can think of we will need to extend a VPN to support new options or extensions, and I don't know what else, but this is probably an open discussion and question for the chairs.
So any comments or feedback on those questions? Can you go to the mic, please?
Maybe I missed it. Did you cover the WAN connectivity, or that's a future use case?
WAN connectivity?
Yeah.
Yeah, so we have a draft in last call in BES. It's called DCI eVPN overlay. It talks about DCI for DC overlay networks, yeah, using eVPN, yes.
Okay, so I think there were a couple of reasons. Thank you, Jorge, for that presentation. Why we asked to have an overview of what was going on in BES for eVPN in NVO3 was partly to get some idea. So it's an applicable control plane for NVO3, although working on eVPN isn't necessarily in our scope. So there's definitely a kind of a discussion about whether or not we need some kind of applicability RFC or something in NVO3 to point to this work, and to show how it fits with the NVO3 architecture. The second issue, I guess, is yes, are there requirements that we are generating in NVO3 that we can input into the work in BES for the evolution of eVPN to support our requirements? Which is so. Yeah, if you don't have any thoughts now, but any feedback on the list would be great.
Yeah, so follow the solution work in the BES working group, and the applicability document will be generated from this working group. I think that's the clarification.
Okay, cool. All right, cool. Thank you.
Okay, thank you. Okay, so next is the 802.1 QCN update.
Okay, this is Yizhou. I'm going to give a quick update on this IEEE 802.1 QC, which is the VDP extension for NVO3 as per the requirement document from the NVO3 working group. Next slide. This is a background. So we have started this project as per this split NVE control plane requirement document, and the draft 0.4 is available at this link, and the password is available. Next page. So next slide, please. So I'm going to give some summary on the progress of this project. We have received both the technical and the editorial comments from the NVO3 mailing list on the most recent draft 0.4. So thank you for all the reviewers. And last week we had the IEEE 802 plenary meeting, and in that meeting the comments had been resolved. Basically, we found nothing controversial. So the current revision, we think, basically meets the needs for the split control plane requirements. And we're going to update it to the draft 0.6 as per the comments resolution. So the comment disposition is available at the following link, and it requires the password. So it's the same as those of the drafts. You may also contact the chairs for the password and the reviewers. So please try to find this comment disposition, and you may talk to me on what your opinions. Okay, one more thing is because the QCN, which is the standard number, has the ambiguity because IEEE has another project called QCN with the name quantized congestion notification. So we are going to change the standard number QCN to some other numbers, but with the same title. It's still called a VDP extension for NVO3. So don't be too surprised if we change the number later. Next page. So basically what we are going to do is on the IEEE 8021, we are going to prepare the new document draft 0.6 and going to start a working group ballot on it. And at the IETF NVO3 side, we are going to request a working group last call on the requirement documents after this QCN draft 0.6 is ready. So this is the update. Any questions? Okay, I guess that's.
Okay, thank you. Okay, so next. Next to Dehan.
Hello everyone, I'm Lu Huang from China Mobile, and I will present VXLAN GPE extension for CU separated VBNG. And actually, I presented our requirement and listed some solution in Chicago meeting. And this time I will quickly review the requirement and describe our choice on the solution. Firstly, our problem is we are introduce a new architecture of BNG in our network. Compared to traditional BNG, we separate BNG control plane and user plane into two parts. We will deploy control plane in a centralized site and distribute user plan as needed. So between control plan and user plan, there were several interfaces for CP and UP to exchange necessary information. One of the interface is service interface. This interface is for the PPOE or IPOE authentication packet exchange between CP and UP. And we choose VXLAN as the encapsulation protocol for the package, and because in our network most of device can support VXLAN, but furthermore we need the user access port information be carried in VXLAN header. So this part is not standardized in any existing document. The port information include device ID, slot ID, subcard ID, and port ID. So we extend the VXLAN GPE header to meet the requirement because we think this way is it's more flexible and not so complex. As the diagram show, we request a new next hop in VXLAN GPE header for VBNG service header. And we define a VBNG service header to carry the port information. There are flag, next protocol, and node ID, slot ID, subcard ID, port ID, and port type. And also, there's another optional format for the port information, which is interface index. It is specified in IFC 2863, and it's a standard way to indicate a port. But this way is not an explicit way to describe a port, and we have to maintain a mapping table between interface index and the port information. So it's relatively a more complex way But this two-way has their advantage and disadvantage, and we hope we can receive some comments on the choice of this two-way.
Yeah,
Please.
just want to supplement. Sorry, this is Michael from Huawei, and just as co-author, and I want to explain why we need this optional solution, because we have discussed with some vendor, discussed with some operator, and they think maybe the subcar ID, slot ID, and the port ID maybe not enough to help to research this node's location. So maybe need more attributes such as a rocket ID, Sheffer ID, such like this. So it requires a method to mapping this different ID to research way or driving method. So we proposed an optional solution to use the interface index to do this job. Okay.
Thank you. Here is an example of PPO EDAP process. I hope it's helpful for the understanding of the CU separated VBNG, how the new architecture works. I will skip the details, and anyone is interested can read the detail in my draft. And for the next step, welcome your comments and suggestions, and we request for working group adoption. Thank you. Any question?
Okay. All right. Thank you.
Thank you.
Okay, so I think with that, we've got 5 minutes left. Thanks to all the speakers for keeping to their slots. That's great. Any further comments anyone wants to raise? Oh, okay, thank you very much.
If anyone hasn't signed the blue sheet there up in the front, please do sign it.
Especially on the hazard. In my recollection, that's correct. So there were no objections to CCC. Objection to header, I don't see that. It's just personal view. Yes, the problem is that it's very weak response. If you think that
When it's a weak response from the author side, Jenny,
from everybody,
or DT, or
from William reaction,
yeah,
it is what it is. You have any? One way that might is, and I will look at this, remove the references to header CV and publish it.
Yeah, I think that's a real way forward. It's one of the reasons we held CCCV is because it just didn't make any sense to move it forward while certain pending text ahead of it.
Yeah, because again, you notice that when we have.
I didn't like what I saw last time.
finally.
Now, point there you are. What will we use echo generic?
So where are the SFC? What's the status of the SLC solutions?
We introduced a couple new proposals, quite small, medical studies, and their always use of consistency, everything like that.
Right.